Excellent. We have a pretty ambitious agenda ahead of us this evening, and Todd and I are both going to take some time off and on from time to, well, I should say back and forth to do some presenting with you. And once again, as Eric said, I'm Jeff Lukens, and I'm a high school biology teacher in Sioux Falls, South Dakota. And so those are our introductions to this point anyway. The first real activity we're going to be working with is a simulation using TI-Nspire with what's called free body diagram simulations, and Todd will be running through that with us. Next up, we'll have an actual data collection activity that we'll be doing right before your very eyes with a temperature probe. And we'll collect a couple of data runs there and show you how you can do that with TI-Nspire and the probes that you very likely already have in your schools. Next, we'll go on to a difficult concept to get across without a simulation. That would be something with waves and spectrum analysis, which Todd will take you through from his experience in chemistry. Next, we'll pass it back to me, and I'll go through the Science Nspired website. If you've never been to the TI Education website, it is absolutely loaded with activities, and some of the newest, and I guess I dare say the newest activities and most recently loaded activities on that site are for this project we call Science Nspired, and there are many, many activities for all major areas of high school science, biology, chemistry, and physics. And if time permits, we will kind of head toward those bottom bullets there with some things about vectors. We will take a look at some things about diffusion. It's a real important concept, especially in life sciences. Then there's some electron configuration work that we can do with some of these activities. And then finally, we'll finish up with some question and answer time. And we want to honor any questions that you have so that we can, so that you can leave here tonight from this WebEx feeling more confident with your use of TI technology. So we do have an ambitious agenda, and we're going to get through as much as we can, but we also want to be sensitive to the fact that many of you might be fairly new to this, so we want to take our time and make sure that there's a few key things that you leave this hour with.
All right, this is Todd. Now, by the end of this webinar, we should have a couple of things down that as we look at our Nspires. The first thing is to control the parameters of a simulation. The first activity that we're looking at is free body diagrams. And in the free body diagrams, we have a number of sliders that actually create different scenarios on the free bodies. There's also movable points and points that we can pin and allow them not to move, and we're going to show you how to move different objects. The second activity where we're starting to do where Jeff does sweating alcohol, we'll collect data using a temperature probe, and he'll show you how to set up data collection and learn some more about the data collection application. Then Jeff will roll into actually going out to the website and looking at pre-made lessons, PD resources for you guys on the Science Nspired website. He's actually going to show you how to download activities from the website and what pieces are available. There's teacher documents, there's the student document, there's a TNS file, and we'll talk through those. We want to show you how to use the student activities and the teacher's notes so you have some confidence. So you can go and grab this stuff, pull it down, put it onto your handheld, and be able to use it whenever you want in your classes. And then the last thing is to stay in touch with some of the social media, Facebook, LinkedIn. We also are going to continue to have webinars and upcoming conferences. We're going to have the opportunity to go and be at regional T-Cubed conferences or also the national T-Cubed conference, which is every time I learn something and have a great opportunity to spend time with you guys. So we're going to go into our first activity, which is the free body diagrams activity. And hopefully you guys should be seeing my desktop appear for you.
Yep, it looks good. And if I may, so now the all of the meeting controls are available in the floating toolbar. Mine's in the lower right-hand side of my screen. Sometimes they're up at the top. But if you want to access the Q&A window, feel free to click the question icon. And then to access the chat panel, feel free to click that dialogue icon. Thanks, Todd.
Thanks, Eric. All right, what you're seeing right now is the TI-Nspire CAS software. And this looks exactly like the TI-Nspire CX software also. What you're seeing on the left-hand side is a simulation of the TI-Nspire itself. So everything that you would see on the left-hand side would actually be what you would see on the handheld itself as you send it out to the students. The right-hand side is kind of our workspace if you're on the computer. So what I'm going to do is I'm going to change this. This is what you should see, the calculator on the left-hand side, you should see it looking like when you first install your software. I want to show you one other thing, though. If you go up to this icon where it says Handheld plus side screen, if I go to keypad and slide and side screen, what you get is just the keypad. This gives us a little more room. So those of you who like Smart View, or you have a smart board or a tablet or something like that, you can actually touch the keys, and as you touch the keys, they actually light up so the students can see what you're actually doing. So if I wanted to add something, I'm going to mess up my title here, but free body diagrams, I put a space in, and you'll notice that the keys light up as I start to type on them. Now, everything that I do on the handheld, or everything actually I do on the software, can also be done on the handheld. So what you're seeing today isn't exclusive to the software. We would send this document out to all the handhelds so that every student would have this in their hands. So what we're going to do today is, this is one of the activities, free body diagrams, that we wrote for physics early this year. And as I go through it, I want to show you some of the characteristics. First of all, we have these tabs across the top. It says 1.1, 1.2, 1.3. Those are actually pages within a document. A couple of things on this page is we can pull in images. This is an image right directly from the web. We dropped in so that you can actually see, you know, you can bring in a bridge or bring in a free body diagram or something like that for your students to actually do some math on, or some physics on, or some chemistry or biology on. So the second page, and the way I would, there's a couple ways to get to this. This right here is a touchpad. So if I swipe across it, it's a little difficult there. If I swipe across it, you can see my cursor moving in the right-hand window. What I can do is I can move over to point 2. This is if you were on the handheld, and click, and it should go to 1.2 for me. This first page, or this second page of notes, is actually a notes page, and what I've done is I've put in some information for the students to read and go through so that when they get to the simulation page, they know what they're looking at. When we move on to a simulation page, here we have a block sitting on a table. And what we have is we have the weight of the block is 1.8. If I start to change this, you'll notice that my normal force and my weight force start changing. This is what's called a slider, and if we go up and click, so you'd take your finger on the handheld and you'd swipe across until they were on this box, and then click to move it back and forth. So kids could see that the normal force and the weight force are equal but opposite. Following this, we actually have questions. These questions are embedded so the students actually can read the question, they can come down here, and they can actually select whatever they think the correct answer is. Later on, I'll be able to pull that back and actually see what their answers were so that I can quickly assess whether or not they understand the concept that we're going through. So as we go through here, there's a series of questions that relate back to that block on the ramp. So if the downward force of the block causes the weight vector, what causes the normal? So we can talk about the table pushing back. Force on an inclined plane. A lot of times we have this block sliding down, or we have to go out to a simulation on the web. Here we can actually create the simulation directly on the handheld. So here's what we have. At the top here is a little player. And this player is set up on a relationship of this block on the plane. So when I hit start, it actually slides down our ramp. What we can do is we can change the location or the steepness of the ramp by grabbing onto the point. And the way that you grab is you put this little hand right over the point, and you click and hold, and the hand closes, and you can start to change the block. One of the things you'll notice is all the force vectors start to change also along with that. So if we simulate this now, the students can actually see it accelerate down the ramp. We can also change the weight of the block, another slider over here. And we notice what happens to our weight and our normal and our force vector. At the bottom we have our force of weight, force normal, and force parallel. And here we have the angle at which we're adjusting the slider. This is assuming we don't have any friction. As we move forward, again, it goes into a series of questions that we want to know, did they understand or did they get the concept that we wanted them to get? On this particular screen, what we have is basically the vectors that we were looking at earlier, but with just looking at the vectors instead of the block. This is a geometry page, and it's in a split window. The left-hand side is actually the geometric figure that we want them to look at, and the right-hand side is the question, where they would come over and actually answer the question, so they can bounce back and forth between these two. One of the ways to do that would be to swipe back and forth. The other way to jump between these two screens, and it's just practice, is to press Control-Tab. And you'll notice that the left-hand screen has this bold line that runs around it. If I press Control-Tab again, it moves back over to the question side. Same thing, we have another question, giving them different parameters. We can actually write questions in where we actually ask for equations. Another question, this time the question is here, and on this side we actually have a calculator. And so we can do things like, since we have force normal, you can actually write in 5 newtons. Okay? And actually, well, let's just do 5 plus 5. So it'll actually calculate out in that screen for us. And then we can come back over and put in an answer. Same thing here, we have question and calculator. And the last simulation that I really want to show you is this one where we actually have a friction force now. And we can actually change that friction force here, and you'll notice what's going to happen is as I drag this up, that friction force is equal to the parallel force until it maxes out, until the parallel force is equal or greater than the friction force. So you start seeing this slide down based on the friction force. So what we can do is we can hand this off to kids, and instead of talking to kids and saying, okay, this is how it works, you put this in their hands and let them start to play with it. And what they can do is they discover the relationships as opposed to you telling them the relationship. And what's happened in my particular class is a lot of times they learn a lot more when I'm a lot quieter.
Todd, this is fantastic. We have a question about resetting the simulation.
Okay.
Is it possible for the simulation to be reset for the next class? So if a teacher's if a teacher's using one classroom set of TI-Nspires, how can we reset this for the next class?
This particular, if you were using all the questions, what I would have what I've had my students do when I did not have Navigator is I would have them save this document. So where it says free body diagram up here, I would click on that, and I had all my students, oops, don't want to do that. I would have all my students go to File and then Save As, and since it's my document, I would put Morstein, and then I'd do free body, and then I'd have them save it. And normally I had them do that before they did anything in the document. And what that allowed me to do is, when they were done, it was saved under Morstein free body. The next class would come in, and then I'd tell them immediately as they walked into class, okay, open free body diagram. And the Morstein free body diagram would be saved for me, but the free body diagram still would be in the original state.
Great. And it's a read-only file, correct?
This particular file, no, I think this is actually this one actually you can write on. But
okay.
you can make them a read-only file. Yes.
Okay. Great. Thanks.
Okay. Go ahead, Eric.
No, we're in good shape. There was
okay.
There was just that question about the resetting the simulation.
Okay. With the kind of working on the assumption that many of you who are joining us this evening are science people, we know that, or we hope that data collection is an important part of your science classroom and of your students' learning. And I just want to make a couple of comments about TI-Nspire and TI-Nspire CX, which is the newest version of TI-Nspire. Oftentimes when new technology becomes available, that new technology is not compatible with some of the things that you may already have at your schools. And I made really a brief mention of this when I was going through the agenda a few minutes ago. But data collection can be incredibly expensive if you have to continue buying new data collection sensors and you have to continually upgrade all your probes and all that kind of thing. Well, I've got really good news for you, and that is that the data collection sensors that you may have in your schools already that are made by a company called Vernier are usable with TI-Nspire. And the even better news is many of these data collection sensors are usable as is with TI-Nspire. The one that is probably the most commonly used sensor of all is a temperature probe. I know in my biology classroom we use temperature probes quite a bit, along with a couple of other real key learning sensors that we use. But temperature probes are arguably the simplest ones to use, plus maybe the most reliable in terms of no matter whose hands you put them in, you can usually get some pretty good data. And Todd's going to prove that here pretty quick, that even in Todd's hands, we can get pretty good data using some of these data collection sensors. So there's an activity that we're going to do tonight that is actually data collection through the computer, but this entire process works exactly the same way on the handheld. And so Todd is going to run through this with us, and this is one that we call sweating alcohol. And one nice kind of the images you see here shows you one of the really cool things about TI-Nspire CX, and that is not only can you import images, as Todd mentioned when he was doing the previous activity, but those you can import them and they're in color. And that's pretty cool. I know I use CXs today with my students, and they just really were gaga about the fact that things were in color. And so here we have a couple of images at the bottom of the screen of ball and stick diagram or models of water, and then on the right we have ethanol, and we have propanol. And what we're going to do here is actually collect data on the cooling rates of both of these two liquids, of water and of isopropyl alcohol. So Todd is right now sitting in Montana, and he has a glass of water and a bottle of rubbing alcohol close by. And so just to run through a little background information here with, if you go back to 1.2 there, Todd, a little background information. This is just a notes page. So basically you can do an activity which involves data collection, and you, at least in theory, you don't even have to have a handout for it. You could put this entire document right on the handheld. The kids could open the document. There's a little background information here about water as far as its polarity and why it's such a, I call it a magic molecule. It's a really unusual molecule for a liquid. And using this background information, we're going to actually discover some of the characteristics, not necessarily of alcohol, but more importantly of water. We call this activity sweating alcohol, not to make it a goal for the kids or anything, but just to let them know that water is a really unusual substance because it's so sticky to itself. So anyway, we have a couple of pages of notes here, and the kids can just zip through those. So page 1.3 has some more information on it, get a little bit more technical with the big fancy word cohesion. And then when we move on to 1.4, we have a couple of questions that then pertain to the background information. And these are just almost like formative assessment questions. Did you read the information? And are there some things that you may have learned from that? So just like Todd showed you in the previous simulation, you can embed these questions anytime you'd like to in a document. And you'll see when we start looking at some of these documents that are available to you on the web, the questions are already embedded in them for you. So you can do ongoing, continuous, comprehensive assessment as you go through these activities. So we're just going to kind of zip through a couple of the questions here, a little solve and solute question, and we're going to get into the actual data collection here. So this is an application in the TI-Nspire software called Data Quest. And you've probably noticed that the format or the appearance of some of the pages looks different. The notes page just looks like a blank sheet of paper with a bunch of stuff written on it. The question pages are, they're from templates that are available right on the software. This happens to be an application called Data Quest. And when you first plug in a probe, this particular screen will pop up. The TI-Nspire device recognizes or the computer even recognizes that a temperature probe, in this case a temperature probe, has been connected. Okay, so now Todd, what he just did is he plugged in a temperature probe to his computer. And this is even if you don't have very many TI-Nspires, or if you have no TI-Nspires but you have the teacher software, you can demo this right in front of the kids and they can actually see what you're doing and they can see the result of this. So we can see that it's about 68 degrees Fahrenheit in Todd's house right now. I want to show you a couple of things that you can do with this. If, you know, measuring temperatures in Fahrenheit may be sort of heresy for some of you who are not very fond of that temperature scale and you want to measure things in Celsius or even another temperature scale. What Todd is going to do now is he's just going to put his cursor in the red box where it says USB temperature, and he's going to right-click in that box, and he's going to pull up a menu choice that says change units. So we're actually going to keep this in Fahrenheit, and we're going to live this heretical life here this evening for scientists. But we have Celsius, and then our chemistry friends really got excited about the fact that we can measure temperatures also in Kelvin. But we're just going to leave it in Fahrenheit for now because the question always comes up whenever we work with TI-Nspire and with Data Quest, can we change the units? Now, in temperatures may not be that important, but if you're using a pressure sensor, for example, I believe there's 4 or 5 different units that we can use. So the keystrokes here on the computer, simply you right-click in the area you want to manipulate. On the handheld, this is like the most important keystrokes you can probably learn on the handheld. The keystrokes for a right-click are Control and then Menu. Okay, so Control Menu is the right-click for the on the handheld keypad. Okay, so what Todd's going to do is he's going to go over to that gray box over on the left, and he's going to right-click in there, and we're going to change the data collection parameters. So he's going to go down to collection setup. We're going to stay with what's called a time-based data collection. If you're familiar with some of the other data collection formats that we've used in the past, there was one called a time graph, and that's what a time-based data collection is. But Todd's going to go down to collection setup and click on that. And then you will notice that there are some choices that you need to make. If you look at the top of the screen, it looks like a pull down menu, but it's actually pull right menu. If he clicks on that, there's two different parameters you can use here. One of them is called seconds per sample. The other one is called samples per second. This is a really good interpretation problem for the kids. Samples per second, if we left that at 5, which is what it's at right now, that will take 5 data collection readings every second. Okay? And I think that's a little too much. It looks, and you can see what the interval is, 0.2 seconds per sample, and we really don't need to be taking data readings that frequently. So Todd's going to go up to that box, and he's going to select the interval one right up above there, Todd. There you go, where it says rate. And we're going to select the interval, and now it's seconds per sample, and I would like Todd to just select 1 there. So he's going to collect 1 data reading every second. Okay? And rather than 30 seconds, we want to make this a little bit quicker. Todd, go ahead and change that one to 15. So now check this out. We're going to collect data, and it may seem like we can't do a whole lot with 15 seconds of data, but just wait. We're going to collect data for only 15 seconds. So if for some reason a kid doesn't do it correctly or needs to redo it, they've just wasted 15 seconds of their life. And I don't know about you, but I've wasted an awful lot more than that in some of the other things I've done. We're going to, in the interest of time, we're going to bypass those 2 check box, or the box where you can check where it says strip chart and data marker. The only one I've ever considered using is a strip chart, and we can look at that at a later time. But right now, I would leave those unchecked. Because really, those are just kind of some fancy things that you can do with the data collection. So Todd's going to click OK, and now you'll look on the left side of the screen, and you'll see that the data collection parameters have been changed, just as we have changed them. So now we have in the bottom left-hand corner a couple of icons. One of them is like the YouTube start button, and kids have no problem at all understanding what that does. And the other one we'll get to in just a little bit. So Todd's going to go ahead. What he's going to do, and I'm not going to even ask him what his temperature probe is in right now. It's in one of the liquids. Okay? It's either in the water or the rubbing alcohol. So Todd's going to, when he starts this data collection, he's going to pull the probe out of the liquid. So go ahead and do that, Todd. And once the data collection starts, bang, you see automatically there's a graph that appears, and the data is getting graphed. Now, it may not look very good right now, but just hold on, because we've got 15 seconds of data collection, and as soon as it's done, we're going to see something kind of cool. Okay, there we go. So after 15 seconds, the window that the graph is displayed in automatically adjusts to the data that's been collected. And this is a really great learning tool for your kids, and something for them to notice is to look at the scale, not so much on the independent variable or the x-axis, but on the dependent variable, the y-axis. The scale is 65.5 to 65.9. So it looks like we have a huge drop here in the red line that Todd is displaying, but in reality, the temperature only went down less than half a degree, or about a half a degree, over the course of 15 seconds. Okay? So now Todd's pointing right now to the next icon in the lower left-hand corner, and if he hovers over that, it says Store Latest Data Run. Now this is not saving the data run, this is storing it, okay, which is what he wants to do. So he's going to go ahead and store this one. And now what we have available to us is another data collection opportunity. Now this one happens to say run 3, so that must mean we were messing around and had run 1 earlier. But so now, without even changing any of the parameters, if we keep our data collection parameters the same, 15-second data collection, next, Todd is going to just start the data collection. I'm assuming, I can't see him, but I'm assuming that the temperature probe is in the other liquid, which right now is reading at 69.1 degrees. And when Todd starts the data collection now, he's just going to go ahead and pull that probe out of there. And we're going to run this for another 15 seconds. And it's a lot smoother when you do this on your own computer and your own handheld. It may look okay to you. It looks like it's kind of choppy and whatnot. Okay, so now we take a look at the independent variable hasn't changed, time 0 to 15 seconds. But now look at the scale on the dependent or the y-axis. We have a drop of over 5 degrees Fahrenheit from start to finish. This is kind of a cool graph because you can do some really neat things with this analysis. You can look at that and say, oh, Todd didn't get the thing pulled out of there for about 2 seconds, which is just fine because all we care about is that downhill slope. Okay, so now I'll let you people at home play the game. Which one was water and which one was the rubbing alcohol? And some of you are like, oh man, it would sure be nice to see them together on the same graph. Well, by golly, I think we can do that. So Todd's going to click in the little box where it says run 3. And when he clicks in there, he should have a choice to show run 1, whatever that one was. We didn't really do that. Or run 2. There's our run 2 that we did with one of the liquids. And then run 3 was the last one, the blue one. Well, let's show them all, and let's see what we get here when Todd shows all of these runs together. Okay, so that top one, and this is kind of like the Wizard of Oz. Pay no attention to that man behind the curtain. Pay no attention to that top line there. We can go ahead and delete that, but I want you to look at the bottom one. There we go. Look at that. Todd's going to magically adjust this. You know what he's doing? He's just grabbing the axes, and he's just making some adjustments. Under normal circumstances, you would not have to do this, but notice we have the color coordinating or color coding here. The red one was our first run, and the blue one was our second run. So now you ask the students which was the rubbing alcohol, which one was the water. And if they don't quite know which was which, they can actually do this tactily if they take a little water and a little rubbing alcohol and put little drops of this stuff on like the inside of their elbow where it's really sensitive. They can actually feel that the rubbing alcohol will be colder, which means it's pulling heat away and cooling off faster. So in this case, the blue line represents the rubbing alcohol and the red line represents the water. So we use this in biology to illustrate, you know, what as a warm-blooded animal like we are, the privilege of being able to perspire, because water pulls heat away from your body, but it doesn't evaporate really, really quickly like rubbing alcohol does. So we kind of make the comparison between the two and say, what if you did sweat something like alcohol? If you sweated something like alcohol, it would pull heat away from your body so fast. And when I say, where do you get that heat? The heat is generated through cell respiration, which means burning of food, which means pulling heat away faster. So, boy, you'd have to eat a lot more if you sweated something like rubbing alcohol, which kids all think is a great deal. Man, I could eat more if I sweat alcohol. Well, yes and no. If you have enough food to eat all the time, it's okay. But if you're a mouse or a gerbil or a sparrow or some dinky little warm-blooded animal, it's pretty tough to survive because you have to constantly be generating heat on the inside of you. Okay? So lots of stuff you can do with this. This is a very, very simple data collection and very inexpensive. The temperature probe, the least expensive probes there are. We use water for this, just room temperature water, and a bottle of rubbing alcohol. And I'm so cheap, I think I've used the same bottle of rubbing alcohol for the last 10 years. Okay, so very inexpensive. So you can do some pretty cool stuff and powerful stuff with very, very limited resources.
Jeff, we have a question about handhelds because we have some teachers in the audience that have the ClickPad and the TouchPad handhelds.
Yes.
Can you do this type of data collection on a ClickPad or TouchPad?
You can. My recommendation would be that on the ClickPad, TouchPad ones, which are, for those of you who aren't familiar with that, those are like the non-CX versions, the previous versions of Nspire, which are not color. But nevertheless, you can upgrade your current Nspires to the newest operating system. Oh, there we go. That's what we were talking about here. The newest operating system, which is 3.0 or 3. I get the numbers mixed up, but it's 3 point something. And if you have a 3 point something operating system, that will include the DataQuest application. And the DataQuest app, Eric, is, and for all of our listeners, the DataQuest app is what's necessary to do the data collection the way we just did it. But it won't be as cool necessarily because it's not in color. But you know what? If the kids don't know any different, they think it's still okay. Does that help, Eric?
That's great. Thank you, and thanks, Todd, for showing the different keypads in the emulator.
Excellent. Okay, so I think what we'll do is, I mean, we could do the data collection thing. Could be an hour unto itself and even more, but we want to make sure we hit some of the other things that were on that agenda. So let's, Eric, if it's okay with you, why don't we just go ahead and move on to the next item?
Sure, that's great.
Okay, that'd be me. Now, one of the things that I wanted to show you, and it was a great question, is looking at this particular software. We also have if you have the ClickPad, this is the touchpad, and you'll notice that this screen grayscales right away. A lot of times as I build documents, I actually want to make sure that images that I would bring in for color will also look okay in grayscale. And so many times I create documents and I double check them in grayscale, because many images actually look really good still in grayscale. So the next activity that we're going to do is waves and spectrum. And actually today I just did this with my chemistry students. We looked at the line spectrum for hydrogen and helium. And this particular activity is a really tough concept to show students other than we draw it on the board. And so what I did when I started to build this is we started to look at, well, what are waves? And so, you know, what happens when we start playing around with waves? And so as we start to drag and change the frequency or the wavelength of the wave, notice what occurs to the wave itself. Now, this is really, you know, you can do this in black and white, but the color really sets it off when the kids actually see that the color of the wave actually changes as you start to slide along. So that tough concept that you're teaching is saying, you know, when you have a wave that's 491 you know, nanometers long, what color is it? Well, kids don't perceive that a wave's length and the wave's frequency actually has some characteristics to what they actually visibly see. So this gets us started into color. As they move through here, they actually start to do some, going a little fast, they start to do some calculations just like we saw earlier, those split screen. We have a calculator area and they can come down and answer the questions. As we move forward, we actually get into what is known as Bohr's atom. And a lot of questions just kind of leading them to this Bohr's atom. Again, like Jeff said earlier, we have this set of you know, instructions that help the kids figure out, okay, what's going to be on the next screen as we come upon it. Now, what I have here is Bohr's atom. I have a nucleus and I have electrons. And if I go from the first energy level, wherever the electron basically drops from this energy level down to this first energy level, this is the frequency of wave that's actually given off. Now, if I move this down, you'll notice there should be a change in that wave. Now, kids can actually visibly see that as the wave changes. I want to do one thing for you, and I'm going to jump ahead just real quick. This data that's showing up here is actually in a spreadsheet, and it lands in a spreadsheet. And it's captured. But what I want to do is I want to clear this data out. So all I'm doing is I'm going back to my spreadsheet. I go to my calculation, and I press Enter twice. And what it does is it clears out the spreadsheet. It recalculates there's nothing to calculate right now, so it empties those screens. What we want to do is we want to go back to our simulation. And if we look at this, you know, today I'm talking to my kids and we're looking at the Balmer and Paschen series of light. And if you teach chemistry, you kind of have an idea of what I'm talking about. If you don't, this is one of the things that this is actually the Balmer series. When we have an electron drop from the third energy level to the second energy level, what color the wave is? It's actually red. And if we want to capture this, one of the cool things about this software is we can capture the data that's actually being generated. And the way we do that is we actually press the control button, and then we press period. And so press control, period. Notice that my line spectrum appears in the red frequency, you know, just below 660 nanometers. If I increase this, I have a blue line. And I can capture that line also by pressing control and period. I move again. Whoop, I want to keep this at 3 or 2. Capture that line. And now we can start to talk to those kids about what they're seeing through a spectroscope is these lines that are appearing because of this wave that's actually forming. The other thing that's kind of neat is I remember doing this as a student, and the professor saying, well, we have this series of jumps, and this is what it means. And I kind of stared at him and smiled and nodded my head, and I didn't really understand it. But as I start to do this particular one, I'm going to do a control period. Nothing appears on this particular screen. So I'm going to move out again, and I'm going to do a control period again. And do a control period again. And what's happening is we're still capturing data. It's just not inside this viewable window. If I grab and drag my scaling here, you'll notice here come these other points that are out at 1,000, you know, about 1,100, a little past 1,200. And what's happening is this is another series of electron jumps. And this, so when we start talking about the Paschen and the Balmer and the Lyman series of electron jumps, what we're doing is we see one series of jumps here, one series of jumps here. And so the kids can actually start to see what's happening on something that is really difficult to talk about in class. And I have them nod at me and smile. Actually, tomorrow, this activity, we're actually doing this one in class. And it goes through and talks about the Balmer, the Paschen. Here's the description of these. And it kind of wanders through. Here's this spreadsheet. The Nspire has a spreadsheet. You'll notice that the text that I have here is capture LAM, comma 0. What that tells me, and this is for later on, but it actually tells me I want to capture a piece of data that I've defined as LAM, and 0 says it either does it automatically or you have to press the control enter. If this is 0, you have to press control enter. So if I want to clear my data out again, I simply press enter twice and it clears my data out. So I try to write activities or try to get activities that create really tough concepts to teach. And this is particularly one that is difficult for my students to capture themselves. And so I like this particular activity just because it has them generate that line themselves. I think we may be ready to find out where we find all this stuff.
Fantastic. Thank you, Todd. And as Jeff brings up the website, with Jeff and Todd's permission, I think, because we do have some content that we'd like to get to, but we do want to respect your evening and the specified time that we'd set for the webinar. So, Jeff and Todd, do you think we could maybe go 10 minutes past the top of the hour? So about an extra 20 minutes from here?
That's fine with me.
Okay.
That would be fine with me also.
Okay, that'll be some time for the website and then maybe 1 or 2 more activities.
Sure.
Thanks.
Okay, now I know what some of you guys are thinking. You're going, Yeah, that's a really cool activity, that waves and spectrum thing, but I could never make that. Well, neither could I. And there are people who can do that kind of stuff, though, and thankfully they are loyal to TI-Nspire, and they are committed to developing activities not necessarily for them only, even though Todd certainly is going to use that stuff in his classroom, but also for you and for any science teacher who wants to use this stuff. So for those of you who kind of went, man, you know, this is great, but there's no way I could make this stuff. You don't have to make this stuff. The idea of Nspire with this document model is putting these things out on the web in true TI fashion and making them available for free. That's F-R-E-E, free to the science teachers anywhere to download. You can use them on your computer, you can use them on your handheld. And that's the next piece of this, is showing you where you can find this stuff. So I can't assume that you've been to this particular website. This is, if you're interested in looking at this, which I hope you are, otherwise you wouldn't be on the webinar tonight, education.ti.com. This site pops up, education.ti.com. And clearly Nspire is the future of handheld graphing technology for TI and I think for our schools. And so this is what pops up. This is just education.ti.com. So where you want to go once you get to this screen, there's all kinds of stuff here. You can look at products and all that kind of thing. But we're going to go right here to this second tab over, which is downloads and activities. And this is just loaded with amazingly versatile and amazingly diverse stuff. But we're just going to scoot down to Science Nspired. Oh, what did I do there? Science Nspired, which is right down here. And I'm just going to click on that. Let's just kind of get the feel for the anatomy of this page for just a minute. This is one of the newest pages that TI has on their education website. And if you look over here in the left-hand panel, we're going to concentrate on just taking a look at how you access these activities in your particular area of the science curriculum and how you can actually put them on your computer so that you can get them onto your handheld. Now, being a biology teacher, I am going to go ahead and choose biology. When I click on biology, it pops up the subheadings, or the particular areas where at this time, and that's the key three words, at this time, this is what we have available. This is not all we are going to have available, we hope. There will be even more added to these subtopics. And let me just pop up chemistry here so you can see what some of the main topics are here. The Mcafee thing just popped up. So here's some of the chemistry topics. And then under, I'll let you take a look at those for just a minute. Some of the key and main things for each of these subject areas. And then under physics, there are some of the topics that we would have under physics. So let's go back to biology. And I think we'll just go ahead and choose the first one, which is cells. So if we open up that module, if you will, that little subheading with cells, we can see which activities are now available to us. We have this is under just the cell area now. Cell transport, enzymes, cell respiration, photosynthesis, and transpiration. So let's go ahead and take a look at the second one. In any of these, we could look at any of them. But under enzymes, this sort of gives you the format of the Science Nspired activities. And I'm a clod, and I can't get this Mcafee thing out of there, but we'll live with it. Every one of these units starts with what's called a lesson guide, and this is a document that describes what you can find in this particular lesson. Then next we have what's called a bell ringer, which is a very short, typically a simulation or some kind of a video clip that is an interest generator for the kids. There's video clips, there are simulations, there are photos with pictures or with questions attached to them, and so on. And then we start going into the actual activities. Here's a simulation for enzyme activity, where you have enzymes and substrate together in a flask, and you can, like Todd showed you earlier with a slider, you can adjust some of the parameters and the concentrations, if you will, of the enzyme and the substrate, and you can see the result of that. And then typically, most of these activities then end with a data collection activity, and this one happens to be one for enzyme catalysis, and I think we should say catalysis there. But basically, if you've ever done any enzyme activities in your biology classroom, if you teach biology, a standard enzyme activity using catalase, which is an enzyme, and hydrogen peroxide. So just in the interest of showing you how to get to these activities and how to actually use them, if you just go to the link for this particular activity, Need for Speed, and click on that, it will bring up a menu that show you can download these things. So you can download all the files. You can download the student PDF file, the teacher notes, the teacher activity, and the student activity. Any file, I think you're familiar with the DOC files, would be the Word documents, and the advantage to downloading the Word document is you can change it, and you can modify that according to your needs and your own classes. PDF documents, not modifiable necessarily, but they are sometimes preferred because they will stay in the form that they actually were written in. And then the TI-Nspire activities, those all have the suffix TNS, which stands for TI-Nspire. And those are the ones that you can actually put onto your handheld device, the TNS files. Okay. So now what you can see when you get to the Need for Speed, it actually shows you a simulation. If you watch here along the top, it actually scrolls through the different pages. There's page 1.1, and it has a little simulation there of an enzyme that's actually an anabolic enzyme that's producing a bigger molecule out of smaller ones. Shows you what enzymes actually do, which is lower the activation energy in a reaction. Then here we have animation of molecules bouncing around on the inside of a flask. And I'm not controlling this. My hands are not touching the computer right now. This actually shows you a preview, essentially, of what this particular file would be all about. Okay. Now, all of these are essentially the same. All of them have the same format. I'll click on the genetics one over here. We have 3 subtopics: Mendelian genetics, some DNA technology, some cell division stuff. Same thing would be true with all of these modules, and as well as the modules in chemistry. Okay. So if you're really curious about where to find, Todd, I'm hoping I find this in the right place. If you're curious about where to find Todd, oh yes, first try, amazing. His waves and spectrum exploration, it was under the periodic table, atomic structure and periodic table, and there it is, and it's free. And all you got to do is click on it, download it to your computer, and then you can use your teacher software, your computer software, to move files from the computer to your handheld device. Or if you just want to use waves and spectrum as a demo for your students in class, you can just run it right off the computer, show it through a projector if you have one, and onto a smart board. So like I said earlier, we have, I'm not sure how many, maybe 35 to 40 activities already for you. And we anticipate that in the coming months that we will have even more available to you, and hopefully you'll make use of these. If nothing else, you can go on there and just take a look at them and what's available and just watch some of these animations. So again, that's education.ti.com, and under downloads and activities, the Science Inspired area. And believe me, you would be some of the first people to access this, because it has not been live for very long. I think just a few weeks has the Science Inspired material been available to everyone. So nice place to start looking.
Great. So we've got maybe about 10 more minutes. So there was a question about once you download an activity, how to transfer it to the handheld. Mm-hmm. Do we have enough time to show that?
You know, I think if we, you know, I hate to pass the buck here, but basically, as Todd's going to do this for us if he has one. As Todd gets this ready to go, what you need is a USB cord, which comes with the TI-Nspire, and it's got the standard USB on one end, and that plugs into the computer, and then it's got a mini USB on the other, and that plugs into the handheld. And essentially, you open up the TI-Nspire software, and you have the activities on your desktop, or you can put them on a thumb drive or whatever, and you drag them and drop them into the handheld. It's very, very simple, and I know some of you are skeptical about that. It's simple, but it really is. It's a drag and drop thing that is really easy to do, and I think that the description of how to do that is actually in the software, if I'm not mistaken. So I don't know if we want to have Todd show that, or if
do you want to hand off? Do you want to hand off to me, Steve? And I will. I actually, of all things, I don't have a handheld sitting here, but I can still explain it and show how it works. So
great.
Great, and towards the end of this evening's session, I'll also hop online just for a moment and show us where some video tutorials are located. So if you have a question about a specific skill, there are video tutorials out there for those. So thanks, Todd.
Oh, no problem. Well, I opened this another vector components activity, but what you'll notice across your software here is I've had the handheld open the whole time. There's a series of tools across the top here, and these are where you would go to look at different things. The first one is this first one is actually tools for a page. So this would be your menu button actually on the handheld. If you press menu, this is what would appear on a text page. And so these are the things that I can actually do on this page. If I click actions, it gives me some of the things I can do. Q&A or proof. I can insert a math box. And so these are some of the tools that you would explore to do on a particular page. The next slide, the next marker over is actually the page sorter. This looks a lot like if you're doing PowerPoint and you want to rearrange slides. You can actually see all your slides simultaneously, so by just scrolling down, and you can see what's contained in your document. If you want to change slides, I can just grab this slide and move it ahead of the previous one. So it allows you to move slides around where you want them. You might create something and you don't want it in a particular order. You can do it here. This is back to our calculator, our Nspire, our handheld device actually. And this little button again, we can change between different handhelds. We can change between the handheld only. So if you want the kids to see what you're pressing and they can see what they should be seeing, you can do the keypad beside, or we can do the handheld like I showed you we started today. The next one over is a set of tools that you can work with, and so this shows you different math templates. We can use all the Greek symbols that we like to use in science. My kids were making me do E equals lambda nu. They actually wanted me to put nu in my calculations instead of X. So I said, great, we'll go get nu. And I was actually able to come in here and get nu. A catalog of all the features that are actually in the handheld with tips. So if I click on something, it gives me the details on how to do something. Mathematical operations tells us what we can do in different places in the handheld. Unit conversions. I try to hide this one from my kids because it'll actually, if I want to convert between things, here's fathoms, feet, inches, kilometers. A lot of these I don't know, or no, not a lot of them, but a few of them I don't know. Angstroms. Okay, you can actually convert between units. And then the last one is this libraries area, which is a whole other area that we'll have to explore at some other time. the last one is where all your content lives. And this little folder actually shows me two window panes here. The top window pane is actually where all my files are on my computer. So if I go in here, it lists, here's all the folders on my computer that I can find and open up. If I go down here, what will happen, and like I said, I don't have a handheld with me, and I'm sorry I don't today, but as soon as I plug in my handheld, a little name of whatever my handheld's name is will appear down here. What I can do at this point is if I have a TI-Nspire file that I want to, say, drop onto the handheld, what I can do, shouldn't have moved out of there, is all I have to do is grab and drag. So if I want to pull periodic properties, all I do is drag it down to this window and let go. What it'll do is it'll take it and put it in the appropriate place on the handheld, and all you have to do next time you go to your handheld is select Home. And we didn't see this page, but when I select Home, you'll see New Document, My Documents, Recent, Current, whatever I'm working on right now, and Settings. If I want to look up my documents, I would select My Documents, and here's all my folders of stuff that I can open up and work with. And so real quickly, I can actually open up a file that maybe I already built, or one that I transferred onto my handheld. So basically, it's a click, drag, and let go. And if you want to pull it back from the handheld, you would open the handheld down here. You would see the list of files. You can grab onto that file and drag it back up into a location that's appropriate for you to use later on. So those are the tools, some of the tools that are available to you in that little